Hey there.
Hello.
Hey, that works.
Hello.
Hi, Travis. Hi, Phil.
Hey.
Hey there.
How you guys doing today?
Oh, pretty good.
Excellent.
All right,
So,
I'm going to get this show started.
Yep. So we're
Hello.
we're basically ready for you when time's ready to come.
My name is Hardy Pottinger, and I'll be your
let
MC
me-
this afternoon. And to
mute
make it
this guy
clear,
real
I
quick.
grant permission to be photographed during this.
So, are you both going to be presenting,
It
or
says
is just
here
one of you going to be presenting?
in the notes that I should do
I'll
calisthenics.
be presenting slides, and we're just gonna take turns by moving before
But
Travis.
that's not my thing.
Okay. Wonderful.
My thing is yoga.
So, did you
I'm not
want
a
to
trained
go
yoga
ahead and
instructor,
test your
but I think
slides
we're all
real quick,
capable
just
of
to
breathing.
see
So I'd
if
like
they
to
come
ask you
through
all to
screen
try
share?
this out.
Sure. Are we
I'm
okay to
going
stop
do
the screen share time right
some
now?
pranayam, which is
Yes.
Sanskrit for breathing exercise.
All right. Let's give me just a
And
second.
it'd be really
here.
cool if you joined me, but you're under no obligation to do so.
Figuring out how
It's
to do
totally
this
optional.
right. Just a moment.
I'm going to do something called Nadi Shodhana, which
All
is
right, that should be showing
alternate
now.
nostril breathing.
Yep. Looks like it came through
Officially,
fine.
there's a way to hold
Great,
your hand.
and
It's a
slides
mudra. If
transition,
you
great.
know it, then go ahead and do it. But I'm just going to
Wonderful. So you are slated to speak at 2:00. Is that right?
Yes.
Point is,
2:10.
you want to block off
Can't
one
remember offhand
nostril and
exactly.
breathe through
Yeah,
the other
2:00.
one.
So
And then
when
you
we're
can
ready
do
to go
this.
on that,
It's gonna be great.
obviously they'll
Nadi Shodhana
introduce
is
you,
supposed to improve
and then
equanimity
we'll patch you.
and leave you ready to listen. So are you ready? Let's try this. For people who have done this before, this is going to be low-key and gentle. We're not going to be doing skull shining breath. We're going to be gentle. So get your hand ready and let's go. First, let's take a deep breath in and out. You can close your eyes if you want, it's optional. I'm not going to breathe into the mic there. And then take your thumb, close off your right nostril, and breathe in through your left nostril. And then switch and breathe out. And then back in. And then switch, breathe out. And then in. And then breathe out normally. Cool. All right, I'm going to do the rest of this. That's it for my calisthenics. Everyone, please type any questions you have for the speakers in the Code4Lib Con channel. Look for the pin threads at the top of the channel to list your questions. And presenters, make sure you're reviewing these threads and addressing the questions from the attendees. Pitch ideas for the breakout sessions are posted outside. There are probably still spaces available. And lightning talks will be from 10:15 a.m. to 11:15 a.m. tomorrow. There's plenty of opportunity to present. The sign-up sheet should be near the registration desk. Don't worry if it fills up. There's an afternoon group as well. Poster display boards will be set up in the room named Hussey. The crew is working on getting that room set up at this moment. Each poster presenter gets one easel and one 36 by 48 poster and binder clips to attach. Poster presenters. The room should be available for you to set up at 2:45. Please make sure your posters are set before poster session at 3:30, but preferably as early as possible so people can browse during the afternoon break. And I was supposed to display a page over here, and I'm not sure if I can even work this machine. But I'll just leave that. The community support volunteers for this afternoon are Beth Sadler and Anne-Marie Mesco from 1 to 3, and Sujong Herring and Bobby Fox from 3 to 5. They are located at the back of the room and have zebra stripe lanyards. And they were waving, but they're back there. The online community support volunteer is Mike Giarlo, the MJ Giarlo on Slack from 1 to 5. And we'd like to congratulate our 2024 Diversity Scholarship recipients. There are 10 in-person recipients. They're all here with us this week. And I'm going to call up an expert on name pronunciation, Chad Nelson. He's going to do this properly. Chad, the mic's yours.
All right. So the scholarship committee received many applicants this year, and could only give 10 in-person scholarship awards. And those are huge thanks to the sponsors of our scholarships this year, which are Princeton University Library, Innovative, part of Clarivate, For Science, Penn State University Libraries, and Permanent.org. So huge round of applause for our sponsors for our scholarship. And so our awardees for this year are Xingcheng Wang, Yan Yu, Desiree Stukes, Kirsten Valley, Emily Fraser, Doreen Chen, Riley Marsh, Samana Boji, Ariana Alcaraz, and Tuimin Nguyen. And then we also had two, something we did new this year is we have two remote scholars, two people that we wanted to award scholarship awards to, but they weren't able to make it in person. So we gave them an award so that they could take time off, watch virtually, and they are Merit Ibekeme and Farouk Omar Yunus. So I'd like a really big round of applause for all of our scholarship recipients. Thank you very much.
All right, thanks, Chad. And we'd also like to thank our sponsors at the supporter level, Grand Valley State University, University Libraries, the University of British Columbia, the School of Information Faculty of Arts, the Virtual Academic Library Environment, Vail of New Jersey, and Carnegie Mellon University Libraries. All right, now we've got some talks. And first up, we have Grayson Murphy, Wrangling the Past Using Python to Prepare Legacy Digital Collections and ETDs for Preservation.
Hello, everyone. Can you hear me? All right.
This isn't yours.
Yeah,
This is yours?
Yeah.
Somebody already pulled it up first.
You didn't see any of that. All right, so my name is Grayson. I'm the digital preservation librarian at the University of Alabama at Birmingham, not in Birmingham. And today I'm going to be talking about the ways in which I use Python on two major projects this past year. The first is preparing our legacy digital collections for preservation, and the next is preparing our ETDs. So first, I'm going to give a bit of background. What do I even mean by legacy digital collections? So UAB libraries did not start doing digital preservation until 2023. So all of the digital collections that we created since 2006, which totaled over 30, were not in preservation. And so we needed to get those into our newly formed preservation systems. To give you an idea of the scope, it was a little over 3.5 terabytes of data. The majority of it were images, videos, and digitized print materials, and we also had a few oral history collections. This is a picture of the network attached storage server where all of this data lived. And if some of you might know, the company Drobo used to make these. It went out of business in early 2023. So not only was, almost 20 years of our digital collections data not preserved, but it was sitting on a at-risk piece of hardware because it was no longer being supported since the company went under. So I'm going to talk about the myriad of ways that I use Python. I pretty much used it from start to finish in a lot of single-use ways and recurring ways. The first was to get an idea of what the heck I was even dealing with. So there were over 140,000 files that represented all the assets for these digital collections. and I needed to know what everything was without, having the time to go in and look in every single file and every single folder. So what I did was I got Python to print a CSV that listed the names and directory path locations of all non-traditional files. And what I mean by that are things such as hidden files, deprecated file formats, corrupt files, and things like that. And through that CSV, I was able to go in and sort of triage and decide, do we want this, do we not want this? And I then also used Python to iterate through and say, if you find this file extension, delete that file, or move those unwanted files out of this folder, what have you. Another thing that I used Python to do was to merge all of the assets for an individual item into its own folder. So a lot of these collections were organized by, all of the PDFs for the entire collection would be in one folder. All of the TIFFs for the entire collection would be in another folder. And the way our preservation structure works is that we package at the item level, so all of the assets for one item are in their own folder. So to do that, I used Python wherever I could to sort of leverage patterns. I have a poster on that as well. Usually in the naming, the file naming convention, to sort them into their own item folders. And that was really helpful. That would have had to have done that manually, and that just would have been annoying. So the last thing I'm going to talk about more in depth as well is I used Python to assign our preservation IDs, and those IDs were used to inform the folder names and file names. So this is the entire workflow for this project. I'd take a collection through start to finish. I'm going to go through it in painstaking detail. No. So the scripts I'm going to talk about are just this red square part of the workflow. So before I get to the scripts, just a bit of background and context. So we have a naming convention. We colloquially call it a UUID. I'm aware it is not literally a UUID. And so before we put things into preservation, we want them all to be in this naming convention, and that's what these scripts help with. So this first script comes into play when everything for all of the items in a collection are in their own individual folders. And so I would point this script in the command line at the directory that contained that collection, and it would spit out a CSV that I would then use in the next script. And that CSV would print in the first column the directory path, in the second column the existing folder name, and then it would leave a blank UUID column, and I would go in and assign those UUIDs and save the CSV. So that CSV would be fed into this script, which takes it and based on the UUID assignment, it renames all the folders, and then it also renames the files within those folders. I made it a simple GUI only because I found it to be annoying to have to put the CSV file path in the command line. So this was just a way for me to easily click two buttons, find the CSV, and it's ready to go. One last thing on this script is based on how things were named, the files weren't originally named with any sort of convention. So if I had left Python up to its own devices, it would have renamed things in its own Python order, and I wanted to impose a sort of structure to that. So what I did was the script would sort of sort every file type into its own pile and then rename based on a list of preference. And I wanted the preservation master or archival master file formats to be listed first so that in the future, people going into these packages, they would sort of have an expectation of what they could find. So for example, if it's an oral history, the WAV file would always be the first listed file. WAV files are a file type that's considered to be a preservation master or an archival master copy. And then it might be your TIFFs and then your PDFs. So that was one thing I changed about this script for a preservation standpoint, just adding structure. So next I'm going to be talking about the ETD project. ETD stands for Electronic Theses and Dissertation. So ETDs at UAB have been sort of a long and winding road. But for the majority of the last decade, we sort of handed them off to ProQuest to handle. I was not there when that decision was made. Don't trust a vendor with all of your ETDs without preservation, my personal opinion. So within the last couple years, we started an institutional repository, and so ProQuest FTP'd over 3,000 ETDs to us to put into the repository. And then we said, but wait, they need to go into preservation too. And so we got them for preservation. And what we received were zip files that contained the PDF of the ETD. I don't know how those were generated. Sorry, Christina. And then an XML document that was ProQuest's own XML, and then, if applicable, supplemental files. And so rather than just chucking them into preservation, we wanted to do a few things to them. So I needed a script that would prepare them for preservation. So enter ETD prepack. So this is a command line script that does 6 major things. First, it iterates through and just unzips all the ETDs. And next, it pulls select metadata from that XML and prints it to a CSV for our own internal use for processing logs. It also then goes and deletes personally identifiable information from the XML documents. I'll talk about that in the next slide. Then it puts everything in a flat folder structure. I'll also talk about that. And then it assigns the UUIDs and renames the folders and files based on the UUIDs, so much like the previous digital collections project. So this is what ProQuest XML looks like. And there were 2 parts of it that we particularly did not feel warranted preserving. There was a contact tag element that included the student's address and potentially a personal email address as well. And then there was also a citizenship tag element, so country of citizenship. And we felt that this was not worth preserving. We didn't see any use cases for future researchers, and we also didn't want to risk this information getting in the wrong hands somehow. So I used the lxml.etree module to go in and excise those 2 elements, and then it would, output the non-personally identifiable information XML, and that would be the new XML that would go into preservation. Another thing I needed to do is put everything in a flat folder structure. So the ETDs that had supplemental files in them the supplemental files were in a subdirectory, and just based on how we set up our preservation object structure, we have everything in one folder. So what I needed to do was create a function that would go through, move those supplemental files up a level, delete that empty folder, so everything would be in one level, but also ignore the ETDs that were, just, normal, just the PDF and the XML. So this is the function that did that, but one thing I want to point out is I added something to the script where for every supplemental file, it would append the file name with an _SUPP, and I will talk about why I did that in the next slide. So this is the part of the script that assigns UUIDs and renames the files in the folders. Unlike the digital collections project, this script automatically assigns the UUIDs, but it would have user input. So say I processed 1,000 so far, I would put in 1,001 at the prompt in the command line, and then it would start renaming from that order. And then this is the part where the _SUPP comes into play. So again, I wanted to impose a sort of structure on the file order. So I wanted the PDF that was the ETD and the XML to always be the first and second file when you open a package, and then the supplemental files to come after that. And in order to do that, the script would look, and if it found the appended SUPP, it would start counting at 3 with the renaming, and then if it didn't, it would count it would count at 1 and 2. So what that looks like in the end is up top you see that's what the zipped files look like. And this is an example of something that has a supplemental file. So you can see there's an extra folder and then just random supplemental files There was one that had over 200, and I felt really bad for our institutional repository librarian because she wanted to put all of them in, and she had to go through them. So then in the bottom is what the output would look like. So it renamed all the folders, and then within that you can see the UUID is assigned to the files as well. And the main PDF and the XML are first and second, and then the supplemental files are ordered after that. So I want to talk about what translating workflows to scripts looks like. So both of these projects could have been done manually. It would have taken forever, but when you really think about it, the script was just translating what I would have done manually into a script. So a couple of questions I like to ask when setting about a project is, what is the end goal of the workflow? And to me, that sort of informs what you need to accomplish along the way. I think that's it's really helpful rather than just getting started and not knowing where you're going. Another question to ask is, are there limitations for how you must get there? So limitations could be, the resources you have, or even just the kinds of things you want to impose on your workflow, such as, I want all the supplemental files to be named after the main payload of the ETD. So that really informs the caveats that you must build into the script along the way. And then I'm just going to end with script testing and troubleshooting tips. I know this is pretty obvious to a lot of people here, but worth mentioning nonetheless. For scripts that do many things, it's really vital to use and build in functions. And that's really helpful for both testing and just general script organization. So with the ETD script, I built it starting from the first thing it needed to do, that was a function, and the next thing, and then the next thing. And I built it incrementally and tested it at every level along the way. So I knew that rather than just crafting 5 functions and throwing them together, I knew it was always going to work together. That was really helpful in the testing phase. This next point is really important, especially if you're handling material that's considered like archival or like preservation material, is to always run your scripts on test data to ensure they work as intended before touching your real data. Even if something looks really simple, you never know what could happen. You could miss, just one character that could do irreparable harm to your data. So what I did for the majority of these projects is I would just take a small sample of the data that I would be running the scripts on, put that in a test folder, and run the script on it and see what would happen and see if it behaved the way I wanted it to before I actually set it free on the real data. So I went fast, of course. So I have time for some questions. Thank you. Also, I'm a newcomer, so please applaud. I know digital preservation isn't the sexiest thing, so I'm not offended. All right, thank you.
All right, last up we have a 15-minute remote talk. Phil, Salvador, and Travis Brown, integrating digital library platforms, the DIY approach. And
At the American University Library doing media librarianship and video preservation.
Hey, my name's Travis Brown. I'm the Director of Technology at the Video Game History Foundation, which is really just a fancy way of saying tech generalist. So I'm a volunteer, but I help with hosting the infrastructure, doing some side projects to fill in the gaps, and even some IT stuff. So I come I come from a engineering background, which is a little different. So there's a lot of the when it comes to the standards and all the formats and everything for library science. That's something that's kind of new to me. But as an engineer, I started out at McAfee, Intel, and then became a solutions architect at AWS and Twitch. So definitely been on the technology side of things.
So I want to talk for a second before we get started about this way we integrated our library platforms together by talking a bit about what our library is and why we ended up in this situation. So we are a special library. Here's our beautiful library that's just right outside my door there. So we collect materials that help explain video game history. So things like magazines, press releases, behind the scenes materials. Obviously, it looks all very nice and pretty on these shelves, but our goal is we want to be a digital first library because we realize that's how people want to access our collections. So we try to actively digitize as much of these materials as we can. I started 2 years ago at VGHF, more or less, and part of my job was when we started, we had a lot of collections, but we didn't have a library system yet. So the goal was, okay, we need to build something that is going to work for digital access. So we had a couple things to keep in mind when we were selecting our systems. We're a pretty scrappy organization. We are 2 people full-time. It's me and my coworker, Frank. Travis is a volunteer. Travis does this for the love of it. So we needed something that was going to be relatively low impact for us. I asked around, I talked with Ashley Bluer about whether it made sense to run Archivematica, and she said, no, do not do that if you only have one volunteer tech person doing things. So we needed something that was going to be relatively low cost for our footprint with low staffing requirements. We needed something that we could effectively set up and run.
Can we interrupt? Sorry, can you all? I don't know if you can hear this on the stream. We'd like to ask you to restart, given that we had some audio issues on the stream and in the room. Sorry for the.
Oh no! Okay, restarting. Sure thing. Did not realize that. All right. Can people hear us? Is that good now? Okay, I see some movement on the webcam. I can't hear anyone, so let's start again. Okay. Hi there. My name is Phil Salvador. I am the library director at the Video Game History Foundation. We are a nonprofit out here in the Bay Area in California. To explain a little bit about my background, because that is going to matter to this talk, I come from a libraries background. I got my MLIS. I worked at the American University Library for 12 years doing media librarianship and video preservation.
Hey, and I'm Travis Brown. Excuse me. I'm the director of technology at the Video Game History Foundation, which is really just a fancy title for technical generalist. I help with all the infrastructure, all the hosting, cloud services, IT, and a little bit of coding custom projects, which we'll talk a little bit about. So I come from an engineering background. I started at McAfee, Intel, became a solutions architect at AWS and Twitch. So always worked on the technical side of things.
So to explain a little bit about our library before we get into it, as this talk mentions, we kind of integrated our library systems together in a custom way, and I want to explain who we are and how we ended up at that point. So our library, now you can see beautiful picture of the library. So we are a special library that focuses on collecting things that help researchers understand the history of video games. So we don't collect the games themselves as much as we do things like magazines, press releases, behind the scenes materials, those kind of things. And we have a nice, the shelves out here look beautiful, but our goal is we want to be a digital first library. We understand that's how people access game history materials, so that's where our focus is. We actively digitize as much of our collections as possible. So our goal was to find digital platforms that would work for us for a primarily digital library experience. I started about 2 years ago at VGHF, and one of my jobs was to help set up those library systems. We had a lot of collections, but we didn't yet have an access point or a catalog for any of this. So we needed something that could be used for our library catalog, but also as a digital access point. We had a couple things to keep in mind, the overriding factor being that we're a pretty scrappy organization. We are 2 people full-time. Travis isn't even full-time staff. Travis is our volunteer tech director. So not a lot of bandwidth for working on this kind of thing. We did consider spinning up our own Archivematica installation, but we're immediately told, like, don't do that. Like, we don't have the bandwidth to do something like that. So we needed a system that was going to be not just relatively low cost, but relatively low impact from a labor perspective. We needed something that would require as little from us in terms of like dedicated work on the systems as possible. And as a bonus, we really wanted something that would integrate an archival catalog with a digital asset management system. Because again, we're doing everything primarily digitally. It would be nice to keep those together as closely as possible. So we settled on a solution that I think a lot of folks in the archives community have used, which is a combination of using Archive Space and Preservica. Archive Space is sort of our control platform where we do all the actual data management, metadata, structuring of our various objects. And then Preservica handles the digital content as well as all the digital preservation workflows and digital access to materials. We like this solution not just because it handled a lot of the backend for us, but because there was built-in Preservica has built-in integration to work with Archive Space. So hypothetically, getting these two things to talk together, they'd be able to share metadata and be able to act more closely to being a seamless platform. Unfortunately, this didn't really work for what we needed. We experimented with this a little bit, and we found that, without belaboring all the individual issues at play, we weren't really happy with how this integration worked. The built-in integration with Preservica locked us into a very specific way of how things were going to be managed and presented on the digital content side in a way that we weren't happy with the browsing experience, since we're going to be digital first, and that was one of our main concerns. We wanted more flexibility over our materials and how they were going to be presented and how people could interact with them. We talked to some other libraries that also used this cocktail of Archive Space and Preservica and found that they were running into a lot of the same problems. And in some cases, they were doing that work manually, which we really didn't want to have to do. So we had to ask ourselves, okay, if we're doing this kind of integration, what do we need out of this? First off, we wanted it to be one way. We wanted to make sure Archive Space is the control and the metadata is being copied over to our digital platform. Second, we wanted to have more flexible organizational structure for our metadata. Sometimes it might make sense to present things differently in Preservica than how we have it in Archive Space for the sake of making a better browsing experience. We wanted to control what fields sync over, because there are some things that, out of the box, Preservica didn't support. We wanted to make sure, we're syncing relevant fields to digital content and not syncing ones that aren't. But I think another really important part of this is we wanted to be able to customize how those things are synchronized. For instance, in Archive Space, at the very high level for a collection, you can specify conditions for access and use, which are visible throughout every item in that collection. No matter where you are, you can see what the conditions are for using these materials. That notion doesn't exist in Preservica. So it's a case where, like, okay, if we have a collection of 300 items, do we have to manually copy the conditions for access and use to all 300 items in Preservica if we're expecting people to be using that as the browsing interface? Just a lot of those issues. So we talked about it and we realized the best solution was, even though we wanted to do things turnkey, we had to make our own tool. So we designed something that we're called the Basic Utility for Batching and Syncing, or Bubsy, named after the failed video game mascot character Bubsy the Bobcat. He's our unofficial mascot of the Video Game History Foundation. He's close to our hearts. So we decided to make the Bubsy tool, but we realized there were some unique challenges to it. As we mentioned, I come from a library background. I have minimal coding experience. I have some functional knowledge of code for video game related things, but not enough to design a tool. Travis, meanwhile, has a lot of engineering experience, but has never worked with these sorts of library environments and dealing with metadata standards and how to construct metadata. So we realized we had to put our heads together to solve this problem and make this tool. I'm going to hand things over to Travis, and he can explain what that looks like and how we actually did this.
Yeah, absolutely. Thanks, Phil. So yeah, early on when we had evaluations for Archive Space and Preservica, we wanted to take a look closely at this native integration they provided. But once we decided, this wasn't going to be a working path forward for us, a quick look would show that both have an API. So basically, Bubsy acts as a layer in between Archive Space and Preservica as a CLI that Phil can trigger to sync metadata from Archive Space to Preservica. And so initially I thought, like, oh, this is going to be very simple. It's two APIs, but the data formats between them are very, very different. And so what we did is we started working together in a crosswalk document to kind of say, all right, Archive Space has this JSON tag, Preservica expects this mods XML format. And so there are different nested structures within the JSON that have to be kind of logically pulled out and put in different levels within the mods XML. So this kind of approach actually really helped have a point of record for like what we agree on is the approach we're taking on the data transformation. And so you can go to the next slide, Phil. And so you'll see like archive space will have all these multiple subjects or agents, and then that will need to be transformed into different types and have their names and to be represented in mods XML. And so that information is all available. It's just multiple RESTful API calls to get and to construct. And so it was a few iterations of kind of like figuring this stuff out and talking through it. And so when we started out, we finally had a plan as to like how we're going to make this data transformation. It was decided, it was up to me to decide kind of like what I would develop this in. I think for me, Python was a good fix or a good selection because it's a language I'm familiar with. It's actually pretty easy to write and to maintain. But I didn't want to reinvent any wheels. So we're using Typer as a CLI framework, which if you're not familiar, it actually makes creating a Python CLI very easy. And so you just define the methods and you can get some out-of-the-box documentation help commands formatted. And so you'll see like this is the output of Bubsy help. And so there's definitely a learning curve, like the previous talk mentioned, like CLIs can be a little intimidating to some users, but in this case, we have one user and Phil's definitely willing to jump in and use the CLI in his workflow. And so we also use some pretty common open source dependencies. We use requests, which is a very common HTTPS library. We use keyring to securely store the credentials in an operating system portable way. PyCountry to do translations on some of the language codes from one format to another. LXML to build the mods XML. And AnyTree proved really helpful in terms of walking up and down a nested hierarchical structure, which archive space stores things in. So, for example, one of our options in Bubsy Sync is to the inheritance level. Do you inherit metadata all the way up to the master like object level, or just one level up within that group? And so AnyTree really helped writing out logic to navigate up those trees back and forth. And yes, so was it worth making our own tool? Yes, we think so. We now have a high level of control or how these collections are represented. One of the features and advantages of Preservica is a universal access interface. And so we're able to take the catalog of all of our information and then by using Bubsy Sync, getting it how we represent it in that universal access view. And I personally have a better understanding of how this metadata is stored and what some of the metadata standards are. And so definitely was a bit of a learning curve because I would not say either API is well documented, but they are documented. So that's definitely helpful there. I've learned a lot about libraries. Phil's learned a lot about technology and writing out issues and tickets because early on we did find some interesting things. And so we have made some iterative improvements on Bubsy. One of the first things that we found was the performance was really bad because with a RESTful API, you sometimes have to call multiple, you have to make multiple API calls to get all the information about an object. And so we created a caching layer so that all of that stuff can be cached locally. And it basically checks the cache before it goes out to the API. And so what's the future of Bubsy? We actually have another volunteer developer that's going to help us with some of the maintenance and improving some of the writing some test cases and adding even more features. And so we're adding improvements and features along the way as, Phil decides, this is the thing we need to move over because we're working with a new type of object or something like that, then we can continue to grow and evolve Bubsy. And one of the things is after you're writing something to solve a specific need, the initial question you always have is like, am I the only one that needs this? Like, and so, you know, this is kind of like an open call. If there are other people using archive space in Preservica, you know, we'd be interested in understanding what the interest would be in open sourcing Bubsy. There would need to be some work because a lot of the business logic or library logic is baked into Bubsy at the moment. So there'd need to be some sort of generalization layer to basically make your own logic to configure Bubsy. But it's definitely something we're interested in understanding more about and seeing if anybody has any questions on it.
Thank you.
Yep, thank you.
I'm not sure if we're able to take questions or if we just, since we had to restart anyway, if it's good to just wrap here, but.
I think we can take a question if we have time. One in chat asks, is either the A-Space instance or Preservica live?
Not publicly yet. We're still getting things set up still. We're still, I mean, hopefully summer is what we're shooting for right now, but they are live for us, at least in staging currently.
Okay, thanks. Sorry for the confusion at the...
No problem. Glad it worked out.
All right. Let's see. We got a pre-breakout session announcements here. Lightning Talk signups for tomorrow morning are available now on the table across from the registration desk. Breakout session sign up for tomorrow afternoon is now available on the table across from registration. We have breakout sessions from basically now 2:15 to 3:15, and then we have our afternoon break from 3:15 to 3:30. Poster sessions will begin immediately after the break from 3:30 to 4 in the Hussey room. Poster presenters, please be sure to make yourself available at your poster to take questions around 3:30. We'll reconvene in the main session room at 4 for day 2's final block of talks, and the live stream will resume at that time. Thanks. All right, I got more info. Apparently, since the breakout sessions are starting now, breakout sessions will take place in this room or in Vandenberg. And as I read each title, can the person who listed it raise their hand long enough for everyone to see? And if you want to go to that breakout, find the person and follow them wherever they lead you. So breakout 1, archive space, tech updates, and community chat, all the way in back there. 2, patrons and data privacy. I'm not seeing a hand. Oh, over there, back corner. Transcription, number 3, transcriptions, video, audio, and IMAX. Using Whisper, OpenAI, Google AI, etc. I'm not seeing a wave. Oh, back there. And number 4, advocacy and retrenchments. How do we continue our work in this world? Right there. Okay. So that's the breakouts, and it's from 2:15 to 3:15.
If you're not going to a breakout, I'm going to march over to Zingerman's and get a piece of coffee cake if anyone wants to come with me.
Not that I thought it was. That one's good.
Nice, thanks.
I forget we've had these things on for like 8 hours today.
Yeah.
So.
All right, folks, you don't need to stop talking, but there's a break, and there's coffee out there and snacks and all that. So if you need a break, take a break.
Recording in progress.
Well, I guess that's my cue. We got group 6 talks now, and first up we have Susan Hoover, Secrets and Lies, Exploring and Exploiting APIs that are Undocumented, Underdocumented, or Misdocumented.
I don't see anything. Okay, that's not good.
Well,
Name that chord.
I'll get this right out. My apologies. I didn't realize it.
Touch it. Shall we talk about cats?
Always.
These are cats, not dinosaurs.
Oh my gosh. It's not logging on. Why is it not logging on? Yeah, right. Oh no, we're good. I just fat fingered it like 7 times, that's why.
And it's still there.
Didn't like me. Okay.
And you swear I'll be able to see presenter right?
Absolutely. This is you?
Yes.
Excellent. My apologies.
Where's my presenter?
There you go.
Welcome. I'm Susan Hoover, and my pronouns are she or they. I am a newcomer. And I am in the Code4Lib, GIF, and regex camp. For the past 2 years, I've been in my first library job as the Metadata Services Coordinator at the University of Houston in Houston, Texas. For the 35 years before that, I was a software developer, accumulating various progressively more advanced titles, working in industries as diverse as defense. Hey, it was the 1980s, and that's about all there was in Houston since the oil bust. Communications, that is dealing with the bits and bytes level of terminal emulation and file transfer protocols. Project management, boring. And pricing and revenue optimization, where I started out, no lie, actually reading and writing and debugging linear algebra forecasting algorithms, which was deliciously fun. And ended up my 22 years there doing mostly Azure DevOps, which was not. Okay. And if someone can tell me which button to push here. Sorry.
That's weird. Oh, that's why some guy.
Okay. So in this presentation, I'm going to talk about some of the processes and tools I've used when I've had to try to automate a task for which there was no documented API. Give the background, walk through what I tried and the tools I used, and briefly discuss some other tools that are available. And at the end, I was supposed to have a list of references that you could look at in your own time, but somehow that slide got omitted from the presentation, so that will be in Slack. Before I begin, I'd like to point out that this presentation, because I have been in the industry, or the software industry, for long enough to know that you should never do a fully live demo in front of people. So this presentation is a hybrid of static slides and some embedded videos, and I don't know why I decided to do that, but here we are. The videos have no sound, so don't worry if you can't hear anything from the videos. They are briefly described in the alt text, and they are narrated in detail in the presenter's notes if you happen to be looking at those. So as a bit of background, when I first took the job at U of H, I inherited a ton of projects from both my predecessor, who had left a year before I got there, and a colleague who left a month after I got there. One of those projects was a multi-year effort to digitize, describe, and ingest into our institutional repository about 7 decades worth of bound theses and dissertations. So copyright laws have changed over time, we know, so we needed to define the workflow so that the appropriate access control rules were used based on the year of publication. And to simplify the workflow, someone had decided that we would divide the works into 3 groups: pre-1978, 1978 to 1988, and 1989 and following. So the works published between 1978 and 1988 needed special handling to apply access restrictions if the work had visible copyright notice or contained copyrighted third-party materials, or if the work had been registered with the Copyright Office within 5 years of its publication. So we identified about 3,700 works that fell into that category, and I did a little back of the envelope calculations, and that showed that checking those by hand, one at a time through the copyright lookup form, would take at least 6 person weeks of effort. And rather than task my very small team with doing these lookups manually, I thought, hey, let me try to automate the copyright lookup process. So I have multiple tools in my toolbox for calling an API and for extracting meaning from the result, but first I needed an API to call. So I went to copyright.gov and performed a search for APIs. The first thing that popped up was a 2015 document called Report and Recommendations of the Technical Upgrades Special Project Team. And that recommended the creation of APIs for end users. In fact, that report said, among other things, quote, "Of all the suggestions participating parties shared with the project team, perhaps the most frequent recommendation was that the Copyright Office pursue business-to-business capabilities to enable data exchange and batch processing, including the use of application program interfaces, parentheses, APIs." I thought, hey, that sounds promising. So I kept looking on the copyright.gov site, but I didn't find an API page or documentation. My next thought was that I could use the lookup form and examine the request and response. So I found the link to the official public catalog, 1978 to present, which leads to a page hosted on the Library of Congress website at the LOC.gov domain that looks like the UI hasn't been updated since 2009, or maybe that's optimistic, 2004. Now here I have a slight digression. Since the copyright lookup sends me to a page that's hosted on the LOC.gov domain, I repeated my search for APIs or documentation on LOC.gov. This yielded a potentially helpful page called APIs for LOC.gov. That sounded really, really promising. That page does have links to additional APIs and services, which include Congress.gov, Chronicling America Digitized Newspapers, a Z3950 gateway to the catalog, and a linked data service for authority and bibliographic metadata. But there's nothing on this page about accessing the copyright database. The APIs page also links to a digital scholarship page describing how to access the digital materials and congress.gov, including a link to some GitHub tutorials and code examples, but again, nothing about accessing copyright.gov. Since I couldn't find any documentation, the next step was to experiment and see what I could learn from using the forum. Based on what I had seen on the copyright.gov website, I knew I needed to be able to assemble an HTTP request that I could call programmatically that would give me a response that I could then parse in my program to give me the copyright information for work. So when I'm experimenting with APIs, as a first pass, I like to use the browser because, hey, I'm already there, and it contains enough tools to get started. So most browsers have the built-in developer mode that allows you to inspect the network traffic when you request a web page. You might find this feature under Developer submenu of the Tools or View menu, and you might have to enable an advanced setting to get it to appear. But once there, you'll want to examine or view the Network tab so you can watch the request and response. So I went back to this 2009 era form, opened the browser tools, filled in the form with something I knew was in the database, and took a look at the result. So here I've got something that's like this unique string that will never appear in any other title. And just for grins, I gave it the author's name as well. And set title, set name, say OK, begin my search, and it pops up with the one and only result that happens to be the thesis I was looking for. So flipping over to the Network tab of the browser tools and rerunning the query, blah, 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 and making it bigger, Network tab, rerunning the query, and I found out recently you can actually make this a separate window so you can see it. I got a response, and I saw that the raw response body from the browser was HTML, which was not what I wanted, because we all know that you can't really parse HTML very well. This leads to the second tool in the toolbox, curl, which, if you need a quick and dirty solution, is already available in your terminal window. The browser tools allow me to copy the HTTP request in curl format,
Recording stopped.
after which I can just paste it right into the terminal window, which is ugly, yes. And I can see that the output is the same HTML, same raw HTML. Now, suppose I wanted to edit this request to say I want JSON. Well, that's pretty tedious to do on the command line. So that's where I bring out the next tool, which is Postman. And with Postman, I can create a new query by importing the curl command from the contents of the clipboard. And then Postman will parse that command line and put the command, the query parameters, and each header into its own editable field. And this allows us to quickly modify and rerun queries. So in this example, I wanted to go to the accept header and modify it to say, hey, I want application JSON. So I do that, and I rerun my query. And guess what I get? Yes, disappointingly, I still get HTML. So while poking around, I had seen something called the Copyright Public Records System Pilot. So I tried that out, advanced search, same query, title, this inscrutable title, author or creator. Actually, I'm looking for any names to get it as broad as possible. And I immediately noticed an improvement in the user interface. So, and I confirmed that I was able to get the same record back from my query. Transgenerational dependence and family homeostasis as ideological something or other. And you can see that it's actually abbreviated because the real title of this work has about 25 words in it. But if you search for all 25 words, you won't find what you're looking for. So, whoops. Looking at the browser tools, I found that the query initiated from the publicrecords.copyright.gov page was internally making a secondary call to api.publicrecords.copyright.gov, and the HTTP request had a body that contained my filter, conditions. So I experimented a little more, changing up the conditions in the UI and observing how the request and response bodies changed. So looking at the query in detail, I immediately, sorry. All right, going back up one, going down one. There we go. Looking at the query in detail, so I immediately noticed that the interface requires a post command rather than a get command, like the old one. Unlike get, which requires that any parameters be either in the query string itself or the HTTP headers, post takes its parameters in a JSON body. So as we can see by looking at the request tab. So here we have an array of parameters that correspond to the fields and values I specified in the query in the new UI. There's the title, the name, the and conjunctions, and they're specified as a phrase. So we could see that we could easily extend this array with more fields and values. And back in the headers tab, we can see the response headers, and we scroll down a little bit, we'll see the request headers, and we can see that the accept header includes application JSON. Ooh, it's requesting response in JSON format. So let's go look at the response and see what we've got. We've got JSON, hooray. So we see there's two top-level keys, metadata and data. Metadata looks like information about the query, and so you see there's some fields that are available. There's the query strings we queried for. Data is the results of the query. So first we see there's a score, which gives us an idea how close the match was, which is important if you have more than one match. Opening it up, we see something called highlights, and looking at that contains HTML for a brief representation that was shown on the results page. Then there's hit, which contains the metadata for the results record. And we can see that there's a registration, there's a registration number, there's publication dates, publication information. Scrolling all the way to the bottom, there's a registration date, which is what I wanted to extract programmatically so that I could insert it back into the metadata. And then there's other fields that we could extract if we wanted to. So I was pleased to see that I didn't need any magical cookies and needed only minimal arguments to trick the service into thinking it was being called from a browser. I tried different arguments with the curl command until I was satisfied with the result. So next up was to do something with the JSON output. So for parsing JSON from the command line, my favorite tool is JQ, which allows you to walk the structure of a JSON document and extract field values. I found the registration date field, but because I don't use JQ often enough, I had to use the documentation and tutorials, and yes, Stack Overflow, to figure out the right syntax to give me the desired output. And then the next step was to wrap all that into a program. So I had inherited a Ruby toolkit from my predecessor, but I'm just a Ruby beginner, so with some more Stack Overflow searching, I eventually had a Ruby script that looped through a folder of thesis metadata files, queried the API for each one, parsed the output, wrote the registration date back to the thesis metadata, and logged the status messages to the console. I kicked off the script and immediately started getting errors from the API. I updated the script to add some error handling and some sleeps and retries and tried again. And because I was lazy, I wrote my own sleeps. So when I came in the next day, the script was still running. And I looked at the script and realized that my retry logic was doubling the sleep time with every failure. So I fixed that and went on. Later, I got some feedback from my team that they had examined the results and found both false positives and some false negatives. So I tweaked the script and reran it. And this feedback, rerun, fix loop happened a few times until we thought we had gotten it about as good as it was going to get, at which point it was ready to push to GitHub. So it took a few days to get everything working, but this was much faster and more accurate than the manual way.
Plus, it felt good to poke around in the code again, even if it was just a utility script. And with this small project, I was able to illustrate some useful lessons. So first off, experiment. You never know what hidden features and APIs you might find. Second, if your first try doesn't work, dig a little deeper. Third, don't be afraid to learn some new tools or languages and revisit old favorites. Fourth, solicit feedback from your users, and yes, your team are users too, and incorporate the feedback. Fifth, iterate and improve. Sixth, use revision control to save your progress as you go along. Seventh, share your knowledge. So here I am sharing a tiny nugget with you. Thank you for listening.
All right, we have another 20-minute talk. This one by Steve Meyer, Think Big, Act Localhost. Use large-scale data techniques at small scales for ad hoc data analysis.
Oops, actually, let me leave that one up.
Hi, and welcome to the University of Michigan.
That is not what I wanted. Sorry about that. Okay, hi, my name is Steve Meyer. I work as the, can you hear me now? It is on. How about this? Okay. So my name is Steve Meyer. I work at the University of Wisconsin-Madison. And so let's see, what's this talk about? Programming techniques for dealing with data at scale. Now, these techniques are not groundbreaking or new, but that's kind of part of the point. I would put these in sort of similar company with Chad Nelson and Andromeda Yelton's, sorry, is this cutting out? Okay, with their talks. The core question at hand is, can I run a Ferberization-like process over my library's 10 million bib records on a standard laptop? And in this case, I'm imposing a couple of constraints here. Stay within a relatively small amount of RAM, given the size of data that I'm working with, and also try to think about personal computing timeframes, such as just working within an hour or some kind of estimate about that. So why impose these constraints? The answer has to do with analytical computation. The data processing paradigms I'm describing have enabled me to be responsive to data requests that I did not plan for. A database provides optimization for a specific application, but it locks one into a data model. But what if each project has different requirements? That means that the previous data set, while constructed from the same raw inputs, is not structured for a new project's needs. So there's a couple of interesting characteristics of the data at, say, a large library, such as its MARC record set. At UW-Madison, we have over 10 million MARC records to contend with, and in recent years, we've had reason to do analysis over all of them. Over the past decade, our campus has been consolidating libraries in response to requests from departments to reclaim space for teaching and research use. When relocating physical materials, one of the decisive factors is whether or not a given title is available in both print and electronic copies. For those of us that work closely with MARC records for things like Solr indexing, you may spot the challenge immediately. MARC cataloging rules generally dictate that you should create separate MARC bib records for each different format of that a library has for the same title. So enter something like a lightweight Ferberization process. Really quickly, Ferber is an acronym for Functional Requirements for Bibliographic Records. It defines a data model in which we can group or cluster different versions of the same bibliographic entities together. The work is the abstract concept for a given title, and that is realized through different versions that instantiate it. And traditional MARC bibliographic records are understood as representing the Ferber manifestations. So how do I process all of this data efficiently and with the flexibility to meet each project? So what's needed here is a paradigm shift, and I'll hope you'll indulge in some metaphor and analogy. So let me go out on a limb and talk about early hip-hop turntablism and finding inspiration for our IT work. The work that I'm describing to you is inspired by the pioneering hip-hop DJ who used the stage name Grandmaster Flash and is dedicated to my former colleague, Mark Foster. Mark was a 1970s trained computational linguist who wrote code that could cluster our millions of MARC records without falling back on the use of massive RAM. So what does this have to do with Grandmaster Flash, though? To fully appreciate that, I recommend that technologists watch the first episode of the documentary series Hip Hop Evolution. In the early 1970s, Clive Campbell, AKA Kool Herc, a Jamaican-American DJ, imported Jamaican dancehall and sound system culture to New York City, where he would develop his merry-go-round technique. DJ Kool Herc substantially changed our relationship to recording technology and blurred the lines between static playback and performance. However, as innovative as Campbell's techniques were, they were not perfected by him alone. These techniques were further extended and developed by the DJ and producer, Joseph Robert Sadler, AKA Grandmaster Flash. Now, the main issue with early hip-hop turntablism is best summed up by a member of Flash's first hip-hop supergroup, the rapper Melvin Glover, who used the stage name Melly Mel. He remarked, you know, the other guys, they just blended in between records and there'd be this big jumble. It'd be like bap, bap, bop, 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 bap. And then you'd hear the other record and it wasn't even clean. So, Grandmaster Flash embarked upon a series of experiments to solve the problem of smoothly mixing two beats together. The basis of that paradigm shift, as described by Sadler himself in the documentary, was to develop techniques that moves record playback to the desired portion of a song without lifting the needle. Now, Sadler's insight was elegant. In his assessment, the act of picking up the record player's tone arm and setting it back down was the source of failure, despite the fact that this is how record players are supposed to work. He invented a new technique that accurately rewinds a record to the desired playback spot. And I cannot do this really any justice by continuing to describe it with words, so let me just implore you to watch that documentary episode and think closely about what an inspirational lesson we can learn from this instance of artistic and technological innovation. So let's get back to the world of data problems facing library technologists. What my colleague Mark Foster essentially illustrated was the analogous paradigm shift to solving the problem of clustering. Specifically, Mark helped me pay closer attention to my hard drive and sorting routines. I'd like to begin the discussion by jumping to the end here. So I think it's, in a compressed time frame like this, a presentation might be aided by seeing our destination. So let's look at what my final clustered data looks like. The actual data output I produce is generated in the JSON lines format, where a single line in a plain text file is one record. I like JSON, it's simple, it's nearly universally parsable, and it makes for a great wrapper format. You can add lots of more data elements to it. Here we can see an example, not on one line, but in a pretty printed format for demonstration and readability. Now, what work is a collection of things, and so what's a collection in JSON? An array. The top level object here is a JSON array. Each element in the array is an object representing one bibliographic record. The array itself then represents the work, a collection of related bib-level manifestations. These JSON wrapper objects allow me to also merge other data with the MARC bibliographic record. This object structure contains a MARC record as a binary string and also merges in related data like items and e-resource holdings. But the main point of showing you this is that I want you to see that in this example, I have print and electronic copies of the same work. So the clustering task at hand is to put these two things together in this form of combined representation. So how do I know that these records go together? Well, they have data elements that tell me so. The print record has an ISSN, so does the electronic record, and each in their own 022 fields, but what if one of them points to the other in a MARC 776 field, I know that a cataloger has asserted that they are the same title. This identifier overlap among records is a crucial data point that declares that two records should merge into a cluster. The challenge with merging these records together at scale is that we must always be prepared for the case when record number 1 and record number 10 million should be merged. Also, we don't know which record references the other. In other words, I cannot know about all the records that should merge without knowing about the entire data set. So we need our Grandmaster Flash moment. We need a paradigm shift. How do I associate these records with each other in a way that doesn't rely on a massive amount of RAM, such as the amount needed to hold it all in memory at once? So thinking about data processing without relying on RAM boils down to a few things, and it's again easiest to work backwards. First and foremost, embrace the stream. When reading through a set of records, do everything you can to read as few records as possible. Think about how reading mark binary works. Though I might point Ruby mark or mark for J at a 13 gigabyte mark record file, it does not read all the records at once like opening a document. It reads the bytes of the first record, processes it, and then moves on. So the goal is to work with radically smaller numbers of mark records that do fit within very small RAM space. What I want to do here is pre-cluster many smaller batches of records that are good candidates for merging. However, at this point, it's very important to note that I do not need to do the clustering operation all in a single operation. And that leads me to a second principle. When working on data processing tasks, sometimes multiple passes through the same data will be faster than a processing routine in which you read all the data only once. So let's make an observation. Reading and writing from and to your hard disk is remarkably fast these days. So that's an amazing asset that we should try to take advantage of. Ultimately, what I want to do is pre-cluster records into very small but not finalized groups, so they can then be subjected to the identifier matching tests. I refer to these groups as merge candidates. What does it mean for records to merge together by format? Aside from the identifiers, what else would you expect to see in a Ferberized work cluster? In my case, the approach is conservative. It's a lightweight Ferber. The goal is only clustering multiple versions of the same manifestation in different formats. I would expect that the final clustered records would have the same publication date and very close title data. One important attribute of those two metadata fields is that they're single valued. And the significance of that is having single valued data that's generating groups or clusters is accomplished by simply sorting the data. When sorting the data, there's some techniques that we can borrow from the world of indexing that are going to be helpful here. So at this point, we've established that we're going to create merge candidates using publication date and title. We can accomplish this by simply concatenating these fields together. And you can see here that in practice, I would take a first pass through the list of MARC records and reserialize the data so that I can create a sortable file. The format of this temporary merge candidate file is a merge key, an identifier, and then the full record or the full data object. We still do not want to rely on too much RAM to sort these merge keys, so ideally we'll find a mechanism to partition the sorting data into smaller chunks. Essentially, we want to recursively apply the merge candidate concept at the level of these merge keys. In practice, I do this by partitioning all the things that should be near each other into files in the same directory. This form of a merge key will first cluster by year. One option then would be to simply put all the data in folders by year. That would accomplish the task of breaking things up into small chunks in a manner that would drastically shrink the set of merge keys that would need to be sorted. And that will greatly contribute to reducing the RAM footprint. However, we know something about the date distribution that's relevant. Generally speaking, we're going to end up in a case where it takes longer to sort the 2023 file than the 1923 file. So the solution to this is to hash your merge keys. A hashing algorithm takes an arbitrary input data and produces a fixed length string. In our case, we can use cryptographic hashing algorithm without consideration for the security characteristics. So using a SHA-1 algorithm, for example, will produce a 40-character hexadecimal string representation of another piece of data. That other piece of data will simply be this date title merge key. A hexadecimal string just means that the string will be composed of a 16-character set of characters, the numbers 0 through 9, the letters A through F. Essentially, A through F become the numbers 11 through 16. Now, it's important to note that these are not unique identifiers. Every time, they're not unique every time they're generated. Given the same input data, a hashing algorithm produces the same output. And that's important because it means that if record number 1 has the same merge key, or the same hash output as record number 10 million, they're both going to end up with the same hash. Now, one of the very important features of hashing algorithms is that over a large enough set of inputs, they will produce uniformly distributed outputs. Using the examples on screen, what this means is that over a data set as large as my library's mark record, date, title, merge keys, there should be approximately equal number of records that start with the number 3 or the character 3 as the character 4. This means that the hash key characters can be used in the file and or directory structure for the reserialized data. So let's review what's going on with this merge key data sorting strategy. A few of the key aspects to note are that because these hashes are deterministic, we know that all records that share the same merge key have the same publication date and title data. This means that the set of records that share the same merge key form a set of merge candidates. My reserialized output format is a fixed length merge key, a tab character, and a JSON object. And that format serializes each record as a single line in a plain text file. Therefore, anything that can sort a text file can sort this data, such as even the basic Unix sort command. Note also that the RAM required should be constant or deterministic. The uniformly distributed output feature of a hashing algorithm means that sorting the A file and sorting the B file should be roughly about the same size, and therefore they should, the RAM is deterministic because if I know the amount of RAM I need to sort one file, I should know the amount of RAM I need to sort any file. Now that's pretty rad, but what's even cooler is that if the RAM requirement is still big, I can just go one level deeper into the hash string. To illustrate this, consider breaking up the data in these files so that one file is not everything that starts with the first character, but the first 2. That creates more files, but they're smaller RAM footprint when sorting them. So to review a couple of principles that have emerged at this point, match your technique to your resources. Determine your RAM first and use that as the target, not vice versa. Multiple passes through the data is okay. Embrace the stream. Don't lift the tone arm if that's where the problem is. And then also, it's really relatively simple that sorting itself is the act of clustering. So the programming techniques that correspond to these principles are all the raw materials that you need. So let's take a look at the macro view of a data pipeline designed to cluster marked bib data from multiple formats. Step 1, reserialize to generate merge candidates. For each record, you're simply going to write out a single line entry, generate a merge key, and then write that file out. For step 2, sort that merge candidate file. Now, I don't have enough time to sort of go into sort of a discussion of a sorting algorithm. I'll just note that I used to use a Ruby gem called file sort. It's still on Ruby gems, I think, but it no longer has a GitHub page. I've created my own Java version that's loosely based on it. An important thing to note is that if you have used hash keys as I've described, the sorting can be accomplished in parallel threads. And that means there's an opportunity to speed up this crucial bottleneck in the pipeline. Given multiple CPU cores, you can work on multiple sections of the data at the same time. My Java library basically does that and sorts multiple independent groups of these records to sort the data more quickly. So I'll come back to this at the end also. Now, once a merge candidate file is sorted, the records that will most likely, but not definitely merge into a cluster are adjacent to each other. This means that I just need to read each line of this file one by one and accumulate a small number of records in RAM until the next line starts with a new merge key hash. And there's basically only two cases that you need to consider. There's only one line for a given merge key, write out a single record cluster, or there's multiple lines for a given merge key, send that off to the identifier matching algorithm. So as shown earlier, each cluster in this scenario is an array of JSON objects, and so my file is in the JSON lines format. So I can't go into the details about the sub-algorithm here, but I will draw your attention, if you take a look at that code, that set theory is your friend here. There's an edge case where you have to be careful about the order in which you encounter records when you what might create a cluster that's that has a size greater than 2, and you have as many identifiers as we tend to deal with in bibliographic description. So what I've described up to this point is relatively simple. Reserialize a large amount of data in a particular way, sort it, reprocess it a second time. If you work in this area, you'd probably recognize this as simply the MapReduce design pattern. The mapping portion is reserializing and sorting. The reduce is the reprocessing in order to generate these clusters. So I'll wrap this up by kind of mentioning that this is a pattern that you can use in many different other contexts. In the data that I showed you originally, the way that I actually merged together item data, holdings data with the bib records is based on this same strategy. It's just the thing that gets subjected to a merge key is the bib ID that's known by all of them. But this means that I can take, over 25 million records, about 26 gigs of plain text data, and still it's memory constant. It just it scales essentially O of n, if you know big O notation. I've also done this to sort of cluster multiple big institutions' data together, not to create format clusters, but just to see where do different libraries have overlap in their collections for the same titles. And then finally, our library actually subscribes to the Web of Science, and we get a copy of the entire raw data set. That data has a particular orientation in the way that the articles cite each other. There was a research team that actually asked for help flipping that citation direction. In the abstract, that looks identical to the way that a Mark 776 field would cite another record. So essentially, I'm at time here, but using our campus research computing cluster, we could run this same process, a large MapReduce, and it scaled well to their parallel compute cluster. So with that, I'll wrap up and just say, think big, act localhost.
All right, we have a 10-minute talk by Sephra Byrne, automation of subject analysis and collection evaluations. And is Sephra here? Yes. Yeah, awesome.
Should be on there. Mm-hmm. Yep, there you are right here. Awesome. There you go. Okay, we're gonna have to go down a little bit. All right, can you hear me well? Okay. Hello, I'm Sephra Byrne, and I'm the data analyst for the Collection Assessment Department at the University of North Texas Libraries. And I worked on this project with Karen Harker, my boss, and our collection assessment librarian. I wanted to start talking a little bit about our collection evaluations, where we've come from in the process of improving our subject analysis, and some of the things that didn't quite work out. So at UNT Libraries, we have to be very conscious of our budget, and so we look at a number of subject-specific collections each year for our collection development department and our accreditation office. In general, we're looking at the needs of the program, our capacity to support the program, the usage of the collection, the quality of that subject collection, and then we dig in and we look at the specific subjects and to analyze which are strong, which may need improvement, and which kind of meet needs. Today, we'll be digging into the most analytically complex of these different analyses, our subject analysis. So we create our collections based off of OCLC's conspectus. This maps Library of Congress call numbers to a subject hierarchy. We can then map these subject-based collections. For this portion of the analysis, we look primarily at summarized numbers, or for like the capacity and for the quality, we're looking at big picture. However, for our subject analysis, we're looking and we're digging deeper into our individual subjects, small call number ranges. The purpose of this is to highlight which specific areas of the collection need the most work, and which are the strongest, which are doing really well. In general, we divide our subjects into the following bins: strong, meets needs, and needs improvement, which is then also split into high, medium, and low priority. This analysis started with Tableau, and I'm sorry this is going to be a little hard to see, but it was very hard for us to analyze it as well. This is us looking at a cross-section of the data, and here we've got, let's see, the color indicates the age of the items in the subject. The size is how many things are there. The symbol shows the general number of the subject. And then on the x-axis, we've got how much ebook usage, and on the y-axis, we've got ILL usage. That's like more than 5 variables there, and that's really hard for our squishy little human brains to process. So this is very hard, and we had to go individually, subject by subject, and analyze each subject. And this just wasn't great. And this doesn't even show journal information. So we moved into Excel. I had figured out how to do power queries in Excel, and this allows our SQL databases to speak directly into Excel and pull our data in directly. This allows us to pull all of the metrics that we could ever want into a single sheet, and we can reuse files by simply changing the collection in our query. We were able to create some custom metrics and ratios between measures so that we can process more numbers at once. However, our analysis was still very manual, as each subject was analyzed individually, taking into account each factor. This was okay for smaller, more limited collections, but as we started to move into more interdisciplinary subjects that naturally have a lot of different subjects, this process became very unwieldy. For example, we went and we were looking at global economics, which was initially assigned upwards of 500 individual little call number ranges. And I was assigned the subject analysis on that one, and I kind of went, maybe let's not look at each one of 500 things. So that was a huge task, but I recognized that we had certain thresholds for what was considered good or bad. I created scores for each of these based off of these thresholds that could then be translated into one of the 5 aforementioned categories: strong, meets needs, and our 3 priorities of needs improvement. The issue with this is that the thresholds I set weren't quite dynamic, and they were chosen for each collection in order to kind of force a normal-ish or uniform-ish distribution on the data. This was a problem because maybe a subject like project management may have a very small number of titles for a business collection, but for a smaller collection like health communications, that might be a very large subject area. So this led us to our kind of current working version where we've kind of got a mixture of dynamic and fixed thresholds. Not everything that we tried ended up working, and I think it's really important to highlight the failures that we met along the way. I did try pulling the data into Python, processing there, and doing regression to attempt to get the scores, but the correlations between this data are miserably bad. We're talking like an R-squared of like 0.07. It was bad. Similarly, we also tried to use some data mining and RapidMiner, but the classification error was above 50% for a lot of models. And if that's about as accurate as rolling a dice, this is just not a great method. So with all that being said, let's get on to how this actually works. Quick peek behind the curtain. We regularly collect a wide variety of data and we store it in our awesome databases so that we just have it on hand. In this specific portion of the analysis, we tap into our ILL borrower data, our data about match rates with choices outstanding academic titles, or OAT, our bibliographic data about our holdings, and our counter usage data. This data is stored in our databases, and we do use Excel's Power Query to be able to just pull it directly into Excel, where we can more easily play with it. So these are our kind of 3 scores that are going to feed into our recommendation. We've got quality, sufficiency, and interest. Our first of these 3 scores is our quality score. This is where we attempt to see the specific measures for recency and our comparison with the OAT list. We rank each subject based on its recency and the percentage of OAT titles held, and then we score the ones that rank highly as a 4 and the ones that rank poorly as a 1, with kind of moderate and okay rankings falling in the middle. By applying this ranking, we solve the issue of having kind of odd distributions that library data is just plagued by. We also force it into a nice distribution so that we get kind of a decent number of subjects for each recommendation. Our second score is sufficiency. This is trying to attempt to answer the question, do we have enough? We start by looking at the straight number of titles for that specific subject. We then look at a couple custom metrics. We call them RBH books and RBH journals. It's pretty much the same thing for both. And we're essentially looking at the portion, we're trying to get a ratio between the portion of ILL requests and the portion of holdings for that subject area, to kind of see, is our ILL requests outpacing what we expect from our holdings? For perfectly balanced collections, we'd expect to see an RBH of 1. Our third score, interest, got split into 2 subscores, one for books and one for journals. We used RBH books for this as well as sufficiency, as ILL is really tricky and kind of exactly where it falls for us. And then we also added in a metric for circulation and our ebook usage. Journal usage, mostly the same, except that we don't consider the percentage of journals used, and we kind of keep it a little bit more simple. We also don't look at print journal usage because that's just not accurate. And then we kind of merge our interest scores together to get a final interest score instead of just books and journals. From there, unfortunately, like showing this in 3D isn't very easy, but we've got our quality, our sufficiency, and our interest there. And so we take these scores as well as kind of the priority of the subject, how closely that subject relates to the collection. And this is how we get our recommendation or our status. As a reminder, these are the strong, meets needs, and needs enhancement. These scores were a way for us to kind of turn our very subjective judgments, us kind of looking at that tableau graph and like, is this good? And turning it into a more rigorous judgment. We do review some of the subjects manually that maybe need a little extra review. From here, we also put in some extra recommendations. Maybe we found that there's more book interest, so we say maybe buy more books, maybe we're low on OAT, and maybe we need to buy print over electronic. We then kind of take this file, we clean it up a bit, and we send it off to our collection development department. So, gonna wrap up here. Future directions, we need some better zero and null handling, and we need a little bit more of our dynamic parameters. And I'd like to move some of our ratios into our actual database tables so that I can get better distributions and we can kind of look at the differences between like a STEM collection and a humanities collection. So, thanks for listening. Yeah.
Okay, for the last talk of this session, we've got a 10-minute talk by Tiffany Tawzer and Christopher Berger. Move fast and fill things using Python for full text retrieval.
Great. Hi, I am Tiffany Tawzer.
And I'm Christopher Beeger. I'm our Access Services and Operations Manager at Loyola University Chicago Health Sciences Library. And this is our first Code4Lib.
Today we're going to be talking about using a Python script for full text retrieval of articles. Back in about 2022, we were starting an evidence synthesis service, primarily providing support for systematic reviews, which is something we'd had demand for a long time. But we are a very small library. There are 5 of us, including our director, with no systems support and only 1 reference librarian. Systematic reviews are already a complex process, and manual retrieval of full text, getting into the numbers of articles that we were pulling, is extremely time-consuming.
So I'd used Python and Selenium previously for an internal project to automate data entry in one of our in-house databases that lacked API access. And once we restarted that full text retrieval service, it was pretty apparent that that script could be adapted for the purpose of locating the articles. And using that version of the script, we were able to perform automated title and DOI searches via PubMed and Serial Solutions. It's now known as 360 Link. That script was very effective in speeding up the retrieval process, but there was definitely some room for improvement. Before we could run the script, we first had to extract info from our EndNote export. And since Selenium is primarily a browser testing platform, it effectively took over the entire computer. It would open hundreds of tabs at once, and that had to be harvested via a browser extension in case the browser would crash.
I came onto the project after a couple of months of Christopher using the script. I had a little bit of coding experience. I had some ideas on how to improve the efficiency of the script that he was already using, to reduce some of that computing overhead, continue to reduce the active staff time, and to simplify the citation information so that we could use the same field regardless of where the citation came from. We also didn't want to have to edit that EndNote file export once we got it. So I'm primarily an ad hoc sort of coder. I had a little bit of Python experience, but I learn as I go, as I need it. So I didn't have a robust background in it. Most of the decisions I made were for expedience of getting a working script out kind of as quickly as I could. I decided to use the Pandas library for data handling, largely because it can work directly with Excel, so we didn't have to worry about file conversion, but also because I find data frames a sort of conceptually easy thing to work with, easier than lists or dictionaries, for instance. I was already familiar with the eUtilities API searches from the National Library of Medicine. In particular, I used the eSearch tool to search PubMed, which returns a PubMed ID, PMID, in response to a query. And like Christopher said, our link resolver is 360 Link, and it already has a built-in link syntax that searches our holdings based on a PMID. So it was a really easy step to build a URL that would function. Sorry, I don't know what it's doing. Okay, so this is an overview of what the script actually does. It imports all of the citation data from the Excel file that we needed, run an exact title search in PubMed on the article title, retrieve PMIDs if the search returned a single result. If it returned 0 results or more than one, we used a Google Scholar title search URL instead. Otherwise, it inserted that PMID into the 360 link URL that I talked about previously. We could then add all of those URLs back to the citation data and write them back to the original Excel file. And from there, we could use a really nifty browser extension called Open Multiple URLs. And this let us open those links in batches, so the process was really interruptible, but it was also really easy to closely associate those files to the citation data, which was important for then handing it back over to the systematic review team. This is just my original working code, which was very messy and has some extra data frames where I didn't need them, and several extra steps that later I discovered I could have done without. But it was working, and that was the important part.
So from the very beginning of this process, it was clear that this script could be used for other full text gathering purposes, aside from our evidence synthesis service. Most notably for us was in ILL lending. So our ILL service runs on Iliad, which has a custom request search function that is primarily used for data collection, but we found that we could use the custom search function to generate a complete list of all of our outstanding LEN requests across Rapid, OCLC, and DocLine. And once we had that full list, we could then export via Iliad into Excel, and we could then run them in one batch through the retrieval script. So here's an example of what that custom request search looks like. To go even faster, we created some custom search parameters that exclude LEN requests that don't meet our reciprocal or max cost fill criteria. And that has the effect of reducing the number of articles that the script then needs to retrieve. And it also reduces the number of LEN requests that we fill in errors. So what have been the results? So as you can see from the first chart here, as compared with our previous manual retrieval process, bearing in mind that ILL requests have been a little bit down across the board, we've basically maintained our fill rate, the number of articles that we fill. And from the second chart, you can see that our turnaround time has actually come down considerably. And in this chart, you can see that not only have we improved our own internal turnaround time, but we're coming in consistently under the average fill time among our Rapid peers. So adapting the script in this way has dramatically reduced the staff time required for ILL lending, so much so that it's actually changed some of the staffing needs at our library. Our ILL role has now transitioned into more of an administrative role with ILL duties.
I've continued to work on that original e-utilities-based script. First, cleaning it up, using some better methods than I originally did. I'm working directly with the list instead of a data frame for the URLs. I experimented with an open access API that didn't really work out very well. We implemented documentation and version control with Git and GitHub. And then I have since incorporated an API from libkey, which will search open access, search our holdings, and often go directly to a PDF download, not even a page with a download, directly to the file, which has smoothed the process even further. This is the current one, and the most thing that I want to say is it's doing more in the same number of lines.
We will see you all at the football bowling.
All right, I have some announcements. Poster presenters, please go collect your poster before you leave if you want them. They will not be kept overnight. Have you enjoyed your conference experience? Hey. Let's make sure it happens again next year. We're looking for a host for 2025. If you're curious about hosting and would like more information about this amazing opportunity, be sure to join us in the C4L25 breakout tomorrow. If you are giving a lightning talk tomorrow morning, please visit the podium between 8 and 8:45 a.m. to load your presentation onto the computer. And tomorrow morning, suitcases can be stored neatly on the wall at the back of the ballroom. Let's see, the community support volunteers for the evening will be wearing black and white striped lanyards. Reception CSVs will be Bobby Fox and Beth Sadler. Are there any social event announcements? All right, well, you can use Slack if you need to let people know things. Reception logistics. The reception is at the Folding Warehouse from 6:30 to 9 p.m. There will be bus transportation available to and from the venue. The bus will be picking up at the North University Avenue entrance of the Michigan League, this building, starting at 6:30 p.m. And come prepared to fold. We have several lanes reserved. No badge or name tag is required for entry to the reception, but don't forget your drink tickets. They're in your badge. If you're giving a talk tomorrow morning, please arrive between 8 and 8:45 a.m. to load your presentation onto the podium computer. And please don't forget your badge and lanyard tomorrow morning. Put it somewhere handy tonight so you don't forget to grab it on your way out the door in the morning. And that's it.
Okay, team. For the reception, buses are going to be out there starting at 6:30. We're going to run a bunch of them to get you there. Take your ID. I don't know why you wouldn't have your ID, but take your ID. That's all. Bye.